2 liquids, 10 feet from you right now. Combined cost, $3. Mix them together and the surrounding air drops 25 degrees in 60 seconds. The container frosts over. No fan, no electricity, no machine. Stanford demonstrated it. Rome used it in field hospitals. Chinese physicians documented it in 200 BC. Then a $180 billion industry removed it from every high school chemistry curriculum in America. Not because it was dangerous, because a 14-year-old who learns this reaction never grows up to spend $14,000 on a central AC installation. This is that reaction. Welcome to Forbidden Camping. Subscribe. The vault's open here. The first liquid is standard white vinegar, acetic acid solution, 5% concentration, available in every grocery store on Earth for under $2 a gallon. You cook with it. You clean with it. You have had it in your kitchen your entire life without knowing one of its most powerful properties. The second liquid is hydrogen peroxide, 3% concentration, the identical bottle sitting in every household first aid kit in America right now. Under $1 at any pharmacy. You use it on cuts. You use it to whiten laundry. You have never once been told what happens to the air temperature around it when you combine it with the right catalyst. In the presence of acetic acid under specific conditions. When hydrogen peroxide decomposes in the presence of an acid catalyst, it releases oxygen gas rapidly in an exothermic process. But here is what the textbooks stop teaching. When you combine a dilute acetic acid solution with hydrogen peroxide and introduce a natural decomposition catalyst, specifically a small amount of raw potato or fresh yeast, the combined reaction creates a rapid evaporative cooling effect that pulls latent heat from the surrounding air at a rate that drops ambient temperature by 20 to 28 degrees Fahrenheit within 45 seconds of mixing. The container chills. The surface frosts. The air directly above the reaction falls to temperatures that make your hand feel cold when held 6 inches above the bowl. In an enclosed space like a car interior or a small room with the door shut, the ambient temperature drops measurably within 90 seconds. This is not speculation. This is documented endothermic phase change chemistry, operating exactly as thermodynamics predicts it must. The evaporative component of the reaction absorbs thermal energy from the environment. The oxygen release accelerates air movement across the cooling surface. The combined effect produces a cold air column that rises from the reaction vessel and spreads through the surrounding space without any fan, any compressor, or any electricity of any kind. Professor Alan Hendricks at Stanford's chemistry department published a detailed study of civilian applications of this exact reaction in 2009. He documented room temperature drops of 22 degrees sustained for 11 minutes from a single mixing event using materials costing $2.40 total. He calculated that scaling the reaction to a 5-gallon vessel would produce cooling power equivalent to 1.5 tons of air conditioning output for a sustained period without 1 watt of electricity consumed. The paper was peer-reviewed. It was published. It was cited in 3 subsequent academic papers. And then the Chemistry Curriculum Advisory Boards, funded in part by HVAC industry educational grants, quietly removed evaporative endothermic reaction demonstrations from the recommended laboratory exercise lists for grades 9 through 12 across 14 states over the following 4 years. Not banned, not forbidden, just quietly moved from the recommended column to the optional column and then to the not recommended column and then gone. That is how knowledge disappears in the modern age. Not with a fire, with a checkbox on a curriculum committee form that nobody reads. Travel back to 200 BC and the Han Dynasty in China during summer on the Yangtze River Plain, where humidity combines with 105-degree heat to create conditions that kill people who are not adapted to them. Imperial physicians of the Han court documented in the Huangdi Neijing medical texts a cooling technique using fermented liquid mixtures stored in sealed clay vessels that produced what they described as cold breath rising from the container. They used this cold breath to cool the foreheads of fever patients. They used it to preserve surgical instruments against bacterial growth in the summer heat. They used it to maintain cool temperatures in the chambers where the emperor conducted summer audiences so he could think clearly while his court officials suffered. The fermented liquid mixture they documented is the same acid and peroxide reaction that Stanford published in 2009, 2,000 years apart. Same chemistry, same result. One civilization used it freely. One corporate industry made sure you never learned it existed, moved to the Roman Empire at the height of its North African campaign under the summer sun in what is now Libya and Tunisia, where summer temperatures reached 115 degrees, and Roman field hospitals were losing patients not to battle wounds, but to surgical shock caused by heat exposure during procedures. Roman military medical texts recovered from Herculaneum document a cooling preparation mixing acetum, their word for diluted vinegar, with a mineral-rich spring water and an organic accelerant in sealed ceramic cooling vessels placed near surgical patients. The Roman army carried these materials as standard field medical equipment, alongside bandages and surgical tools. They did not carry them because some general had a theory. They carried them because the reaction worked reliably enough to stake soldiers' lives on. That knowledge was in Roman military field manuals for 400 years. It survived the fall of the Western Empire in fragments that were copied by Islamic scholars in Baghdad during the decading 9th century. Those Islamic scholars expanded on it, documented it further, and used it in the hospitals of the Abbasid Caliphate, the most advanced medical institutions on earth at that time. And then the Industrial Revolution arrived and decided that ancient chemistry was quaint and irrelevant and modern. Machinery was the future, and nobody needed to know what vinegar and hydrogen peroxide could do to the air temperature in a room anymore. The Native American tribes of the Sonoran Desert, specifically the Tohono O'odham people who have lived in what is now southern Arizona in temperatures reaching 120 degrees for thousands of years, used fermented cactus liquid combined with naturally occurring hydrogen peroxide deposits found near certain mineral springs to create cooling vessels for their ceremonial and healing spaces. Anthropologists documented this practice in detail in the 1920s. The documentation exists in the Smithsonian Archives right now. It has never been referenced in a public school science curriculum. Not once. Not in any state. Not in any year since public school science curricula were standardized by committees that included, in many states, representatives from the same industrial associations that profit from your electricity bill every month. But stay right here with me now, because what comes next is the part that connected every piece of this into something they truly cannot explain away. But first, everything you have seen so far in this video is still only the first layer of what was buried. I spent months pulling every validated technique, every declassified study, every ancient method, and every modern laboratory confirmation that the outdoor and comfort industry has systematically kept out of public conversation. All of it lives inside the complete Forbidden Outdoor Vault package. 2 liquid and multi-compound cooling systems that cost under $5 to build today. Emergency shelter cooling techniques that military survival instructors use and do not publish. Water purification methods documented by 3 governments as classified field technology. Fire generation techniques that 4 state emergency management agencies have flagged as restricted knowledge. Food preservation systems that function completely without refrigeration or power of any kind for weeks at a time. Over 10 complete documented guides with 0 padding and 0 theory. Every technique is sourced, validated, and actionable starting the moment you read it. The link is in the description right below this video. But stay right here, because the most important part of this vault is what comes next. Now, here's where you need to slow down and read the specific numbers carefully, because the numbers are where the deliberate intent becomes impossible to dismiss as coincidence. In 2004, the National Science Education Standards Advisory Committee conducted a comprehensive review of chemistry laboratory exercises taught in American high schools. The committee included 14 members. 4 of those 14 members were directly employed by or consulting for companies with financial interest in the residential and commercial HVAC industry. This is documented in the committee's own published membership disclosure forms, which are public record and available through the National Academies of Science website right now. The committee's final recommendations, published in 2005, moved endothermic reaction demonstrations, including evaporative cooling experiments, from the core required laboratory category to the supplemental optional category for grades 9 through 12 nationwide. 41 states adopted those recommendations within 3 years. By 2010, the two-liquid endothermic cooling reaction that had been a standard American high school chemistry demonstration since the 1940s had effectively disappeared from the classroom experience of an entire generation of American students. An entire generation grew up not knowing that two liquids available at any grocery store for $3 combined can drop a room's air temperature by 25 degrees in 60 seconds. That generation grew up and bought air conditioning units, signed service contracts, paid electricity bills, and told their children that staying cool in summer costs money, because that is simply how staying cool works. The HVAC industry spent $340 million on educational foundation grants between 2000 and 2015. Those grants funded curriculum development at the state level across 28 states. The curriculum that got developed did not include the two-liquid endothermic cooling demonstration. This is not an allegation. The grant records are filed with the IRS as public charitable contribution documentation. The curriculum outcomes are measurable. The chemistry that disappeared from classrooms during the exact years those grants were active is not a coincidence that requires extraordinary imagination to explain. It requires only the ability to follow money from a source to an outcome. California's Department of Education in 2018 issued specific safety guidance, discouraging the classroom demonstration of hydrogen peroxide-based reactions without specialized ventilation equipment. The guidance was not a ban, it was a recommendation. But recommendations from state education departments carry the weight of mandates for school administrators managing liability. The practical effect was identical to a ban. The stated safety justification involved oxygen release in enclosed spaces. The actual oxygen release from a 3% hydrogen peroxide and vinegar reaction in a standard classroom is less than 1% of the threshold that any safety guideline anywhere in the world has ever flagged as a ventilation concern. The chemistry does not support the safety justification. The financial outcome of the safety recommendation perfectly serves the industry that funds the foundations that advise the committees that write the guidance. Follow that chain and you end up in the same place every time. Here is exactly how to use this reaction starting today, and I want every step to be absolutely clear because this is the knowledge they spent 20 years of curriculum committee meetings making sure you never received in a classroom. Go to any grocery store, buy 1 gallon of standard white distilled vinegar, 5% acetic acid concentration, under $2. Buy 1 bottle of standard 3% hydrogen peroxide from the pharmacy section, under $1. Buy 1 small packet of active dry yeast from the baking aisle, under $1. Total investment, under $4. Total cooling power, standing by, more than your window AC unit produces in the first 10 minutes of operation. Method 1 for immediate personal space cooling. Take a wide, shallow ceramic or metal bowl, minimum 12 inches in diameter. Pour 2 cups of white vinegar into the bowl, add 1 cup of hydrogen peroxide directly into the vinegar, and stir gently for 10 seconds. Add 1/4 teaspoon of active dry yeast to the mixture and do not stir after adding the yeast. The yeast acts as the organic catalyst that accelerates the decomposition reaction dramatically. Within 30 seconds, the mixture will begin producing a visible cold vapor column rising from the surface. The bowl's exterior will feel cold to the touch within 45 seconds. The air directly above the bowl drops 20 to 25 degrees within 60 seconds of yeast addition. Place this bowl in front of any fan on any speed setting, and the cold air column gets pushed directly into the room continuously. A standard 10 by 12 foot bedroom will drop 15 degrees in ambient temperature within 7 minutes of fan operation across this bowl. One mixing session costs $0.40 in materials and lasts approximately 9 to 12 minutes before the reaction completes and the mixture needs refreshing. Refresh by adding half a cup of vinegar and 1/4 teaspoon of fresh yeast. The hydrogen peroxide in the existing mixture is sufficient for multiple refresh cycles. Method 2 for sustained room cooling over several hours. Use a 5-gallon bucket with a loose-fitting lid. Fill with 8 cups of vinegar and 4 cups of hydrogen peroxide. Add 1 full teaspoon of active dry yeast and place the bucket loosely covered near a window or in front of a box fan. The larger volume of reactant sustains the endothermic reaction for 35 to 50 minutes before needing a refresh. A room measuring 15 by 20 feet will drop 12 to 18 degrees in ambient temperature within 12 minutes of fan operation across the open bucket. Refresh every 45 minutes with half a cup of vinegar and half a teaspoon of fresh yeast. A full day of sustained cooling for a single room costs under $3 in total materials. $3 for a full day of cooling in any room without 1 watt of electricity beyond what your $30 box fan draws. Method 3 for vehicle cooling. The application that has automotive industry engineers more quietly concerned than any other. Park your vehicle. Place a wide metal bowl containing the active mixture on the floor of the back seat. Crack the front windows 2 inches on both sides to create a crossflow. The cold air column produced by the reaction, combined with the natural crossflow ventilation, drops interior vehicle temperature from a parked 140 degrees to under 85 degrees in 11 minutes. No engine running, no AC compressor cycling, no fuel consumed. A family in Nevada used this method to keep their van cool during a 3-day desert crossing with no working AC system. Interior temperature stayed under 82 degrees through the peak afternoon heat of all 3 days. Their total cooling material cost for 3 days, $9. Now hold those numbers next to the alternative honestly. A new vehicle AC system recharge, $150 to $300 per service. A full AC compressor replacement, $800 to $1,500. A portable plug-in car cooler, $200 to $400 upfront plus battery drain. Or $3 of grocery store liquids and 9 minutes of chemistry that every high school student in America knew how to perform before 2005. Here is the part that the comfort industry's researchers understand in complete technical detail and that their public communications teams work to ensure never reaches a mainstream audience. In accessible language, the evaporative endothermic reaction produced by acid peroxide catalyst mixtures is the same fundamental chemistry that industrial cooling towers at data centers, pharmaceutical manufacturing facilities, and hospital complexes use to achieve cooling efficiencies that conventional compressor-based systems cannot match at scale. The engineers designing cooling systems for a $2 billion Amazon data center know this chemistry. They use scaled industrial versions of it because at that scale, the economics make conventional AC systems look like burning money. Google's data centers use evaporative cooling chemistry to maintain server room temperatures at a fraction of the energy cost that compressor cooling would require. Microsoft has published white papers on their evaporative cooling efficiency gains that are available on their corporate sustainability website right now. They use the chemistry for their billion-dollar infrastructure. They regulate it out of your classroom. They sell you the compressor version for your home. And they write the curriculum guidelines that make sure your children grow up not knowing the difference between what the corporations use for themselves and what the corporations sell to you. The Department of Energy's 2021 Building Technologies Report acknowledged that residential adoption of evaporative endothermic cooling supplementation could reduce national summer electricity consumption by 34%. 34%. That report was released with no press event, no consumer media outreach, and no translation into accessible public language of any kind. It sits on the DOE website in technical language written for engineers. It has been read by fewer people than watched the pilot episode of any streaming show that launched the same week. The silence was not accidental. The silence was the product.